Section 210.51c5 of the National Electrical Code addresses receptacle placement in appliance garages. This section specifies that receptacles located inside an appliance garage are not considered as the required outlets for general receptacle spacing in kitchens. However, it's crucial to understand what this section does and does not imply. It does not prohibit connecting receptacles within an appliance garage to a small appliance branch circuit. The code distinguishes between meeting the minimum number of required receptacle outlets and the flexibility of circuit assignments. This means that while the code doesn't mandate that appliance garage receptacles be on a small appliance circuit, it permits it. To further clarify the application of this code section, consider the following points when dealing with kitchens that include an appliance garage. Firstly, the receptacles located inside the appliance garage are not counted when determining the total number of required countertop receptacles as per NEC standards. Secondly, these receptacles can be connected to the small appliance branch circuit, but such connection is not an obligatory requirement. They could alternatively be connected to a general-purpose branch circuit provided that the circuit meets all other applicable requirements. Now let's discuss the requirements for countertop receptacles in the 1993 and 1989 editions of the National Electrical Code. The 1993 NEC had a specific requirement regarding the number of small appliance branch circuits required for kitchen countertop outlets. The 1993 NEC required two 20-amp branch circuits for counter outlets in kitchens with a countertop over 12 feet of cumulative length. In contrast, the 1989 NEC did not contain the specific requirement mandating multiple small appliance branch circuits in kitchens. Regarding a specific situation involving a house built in 1992, it should ideally have been wired in compliance with the 1993 NEC. This would mean that the kitchen should have two small appliance branch circuits dedicated to the countertop outlets, especially if the cumulative length of the countertop exceeded 12 feet. However, it's important to recognize that modifications or remodels to the kitchen after the initial construction could have altered the original electrical system. If the kitchen has been remodeled, the electrical system might not have been updated to conform to the current code requirements. Therefore, a thorough inspection is necessary to determine the current wiring configuration and ensure compliance with the relevant electrical codes. When evaluating an electrical installation, it's essential to consider several factors beyond just the presence of the correct number of circuits and receptacle placements. Firstly, the proper sizing of conductors must be ensured. The conductors for a 20-amp branch circuit must be sized appropriately to handle the intended load. Typically, this means using number 12 American wire gauge copper conductors. Secondly, the overcurrent protection devices must be correctly sized. A 20-amp branch circuit must be protected by a 20-amp circuit breaker or fuse. Using an improperly sized overcurrent device could lead to overheating and potentially a fire hazard. Thirdly, all wiring connections must be made securely and properly. Loose or corroded connections can create resistance, leading to heat buildup and potential failure of the electrical system. Fourthly, the grounding system must be intact and effective. Proper grounding is crucial for safety, as it provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock. Fifthly, the installation must comply with all other applicable requirements of the National Electrical Code. This includes requirements for wiring methods, box fill, and protection of conductors from physical damage. To elaborate on the subject of small appliance branch circuits, it is useful to understand their purpose and specific requirements. Small appliance branch circuits are dedicated circuits intended to supply power to small appliances in the kitchen and dining areas. These circuits are typically rated at 20 amps and serve only receptacles in the kitchen, pantry, breakfast room, dining room, or similar areas. They are intended to prevent overloading of general-purpose circuits due to the simultaneous use of multiple appliances. The National Electrical Code requires at least two small appliance branch circuits to serve the kitchen countertop receptacles. This requirement helps to ensure that sufficient power is available to operate multiple appliances without tripping circuit breakers. The receptacles served by smaller appliance branch circuits must be readily accessible and located along the countertop. The code specifies maximum spacing requirements for countertop receptacles to ensure that they are conveniently located for appliance use. When installing or modifying electrical systems in kitchens, it is essential to consult the latest edition of the National Electrical Code and any applicable local codes. These codes provide detailed requirements for electrical installations and are intended to ensure safety and compliance. It is also recommended to hire a qualified electrician to perform any electrical work. A qualified electrician has the knowledge and experience to ensure that the work is done safely and in accordance with the code requirements. In addition to the specific requirements for small appliance branch circuits and countertop receptacles, there are other considerations for electrical installations in kitchens. These include requirements for lighting, ventilation, and GFCI protection. Kitchen lighting must be adequate for the tasks performed in the kitchen. The code specifies minimum lighting levels for various areas of the kitchen, such as the countertop, sink, and range. Ventilation is also important in kitchens to remove smoke, grease, and odors. The code requires a range hood or other ventilation system to be installed above the range. GFCI protection is required for receptacles located within a certain distance of sinks and other water sources. GFCI protection helps to prevent electrical shock by detecting ground faults and interrupting the circuit. When planning an electrical installation in a kitchen, it is important to consider all of these requirements and to consult with a qualified electrician to ensure that the installation is safe and compliant. Furthermore, it is important to understand the differences between various types of receptacles and their applications. Standard receptacles are typically rated at 15 amps or 20 amps and are used for general-purpose electrical loads. GFCI receptacles provide ground fault protection and are required in certain locations such as bathrooms, kitchens, and outdoor areas. SI receptacles provide arc fault protection and are required in certain locations to help prevent electrical fires. USB receptacles provide a convenient way to charge electronic devices without the need for a separate charger. When selecting receptacles for an electrical installation, it is important to choose the appropriate type for the intended application. It is also important to ensure that the receptacles are properly installed and wired. Improperly installed receptacles can be a safety hazard. When working on electrical systems, it is essential to follow all safety precautions. This includes turning off the power to the circuit before working on it, using insulated tools, and wearing appropriate personal protective equipment. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent injury. Also, understanding the concept of electrical load calculations is crucial for ensuring the safety and efficiency of an electrical system. Electrical load calculations are used to determine the total amount of power that will be drawn by all of the electrical devices and appliances in a building. This information is used to size the electrical service, feeders, and branch circuits. The National Electrical Code provides detailed guidelines for performing electrical load calculations. These guidelines take into account the type of building, the size of the building, and the types of electrical loads that will be present. When performing electrical load calculations, it is important to consider both the continuous and non-continuous loads. Continuous loads are those that are expected to operate for 3 hours or more at a time. Non-continuous loads are those that are not expected to operate for 3 hours or more at a time. The National Electrical Code requires that continuous loads be multiplied by 125% when calculating the total load. This is to account for the fact that continuous loads can cause the electrical system to heat up more than non-continuous loads. It is also important to consider the demand factors that are allowed by the National Electrical Code. Demand factors are used to reduce the calculated load based on the assumption that not all of the electrical devices and appliances will be operating at the same time. The demand factors vary depending on the type of building and the types of electrical loads that are present. Once the electrical load calculations have been completed, the electrical service, feeders, and branch circuits can be sized accordingly. The electrical service is the main connection between the building and the utility company. The feeders are the conductors that run from the electrical service to the branch circuit panels. The branch circuits are the conductors that run from the branch circuit panels to the individual electrical devices and appliances. It is important to size the electrical service, feeders, and branch circuits properly to ensure that they can handle the expected electrical load. Undersized conductors can overheat and cause a fire. Oversized conductors can be more expensive than necessary. Also, the proper installation and maintenance of electrical equipment are essential for ensuring its safe and reliable operation. Electrical equipment should be installed in accordance with the manufacturer's instructions and all applicable codes and standards. Electrical equipment should be inspected regularly for signs of wear and tear. Any damaged or defective equipment should be repaired or replaced immediately. Electrical equipment should be kept clean and free of dust and debris. Dust and debris can accumulate on electrical equipment and cause it to overheat. Electrical equipment should be protected from moisture. Moisture can cause electrical equipment to corrode and fail. Electrical equipment should be properly grounded. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock. Regular maintenance of electrical equipment can help to prevent electrical hazards and ensure its long-term reliability. It is important to hire a qualified electrician to perform any electrical work. A qualified electrician has the knowledge and experience to ensure that the work is done safely and in accordance with the code requirements. In addition to the specific requirements for electrical installations in kitchens, there are also general requirements that apply to all electrical installations. These requirements cover topics such as wiring methods, grounding, overcurrent protection, and safety. Wiring methods refer to the types of materials and techniques that are used to install electrical wiring. The National Electrical Code specifies the allowable wiring methods for different types of buildings and locations. Grounding is the process of connecting electrical equipment to the earth. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock. Overcurrent protection is the use of circuit breakers and fuses to protect electrical circuits from overloads and short circuits. Safety is the most important consideration when working on electrical systems. It is important to follow all safety precautions to prevent electrical shock and other injuries. The National Electrical Code is a comprehensive set of rules and regulations for electrical installations. It is important to be familiar with the National Electrical Code and to follow its requirements when working on electrical systems. The National Electrical Code is updated every 3 years. The latest edition of the National Electrical Code should be consulted for the most up-to-date requirements. In summary, understanding the intricacies of receptacle placement in appliance garages, countertop receptacle requirements in different editions of the NEC, proper sizing and protection of circuits, and general electrical safety practices is paramount for ensuring safe and compliant electrical installations. Always consult the latest edition of the NEC and seek the expertise of qualified electricians for any electrical work to guarantee adherence to highest safety standards and code compliance.